My name is Tomasz Heimowski. Thank you for coming to my session. And you know what? I like F#, I like Fable, I like doing live coding sessions, so basically that's why I'm here. And I use the Heimowski nick on GitHub or Twitter. I also have my webpage if you want to reach out to me later. And we'll try to build a game using Fable in 45 minutes, if you don't count 2 weeks of preparations. Yeah, so that's the thing. And we'll see what we'll be building today, why, what's the purpose of that, and then we'll just go straight to the code. And slides are available, and I'll tweet the URL if you want to see that afterwards. OK, so who recognized that game? Anyone? OK, you don't count. Yeah, what's the name? Almost. The game name is Pang. So the purpose of the game is to shoot balls with a harpoon. So there's a player, and there's a big ball at the beginning. And whenever you shoot a harpoon into a ball, it splits into 2 smaller balls. So basically, you get points for shooting the balls. Yeah. And there are levels in this game, but let me just calm this a little bit down. We won't do levels. Instead, we'll do balls until you lose the game. So we'll do a slightly modified version of the game. And it won't have such a cool UI. In fact, our application, our game will look something like that. And this is actually a screenshot from my Android. So I want to deploy that game, and I want you to compete and play that game on your mobile phones. So we'll focus just on mobile phones today, and actually the game won't be, you won't be able to play all that on desktop. Right. So let's talk about why we're doing this. So first, let's talk about why we are not doing this. So we will not see clean code today. There will be a lot of hackery way to achieve the final goal, the final result. We will not be praising functional purity, etc. So there will be some mutations in the code, so don't be afraid. And that's because we want to interop with JavaScript libraries that need those mutations. So yeah, that's because. And you don't need to understand every single line of code. In fact, I don't either. So if you don't follow, that's fine. Just keep focus on our primary goal, like having fun and building a game. And also, I want to emphasize that we are not here to admire my fast typing. So it took me quite a lot of time to prepare for that. So I don't do this on a daily basis, really. So that's not the point. OK, so what are the goals? As I said, we want to interop with ready JavaScript libraries for building games, a physics one, and a main loop JavaScript library. Then we want to use mutability to gain on performance to achieve high frames per second. And we want to see Fable in action because we saw today a lot of awesome theoretical talks, and now we'll see some Fable in action in practice. And primarily, we want to have some fun. So why not? I want you to compete to achieve the highest score, and actually we have a prize for the first score, and whoever will be the best will get this copy of Isaac's book on Get Programming with F#. So the plan is that I'll deploy the app at the very end if everything goes right. And by the end of Chris' closing keynote, we'll see who scored the best, who did the best score, and he will get the book. So, yeah. And we won't start from scratch because there's just too much. So we'll cheat a little bit. And actually, the game prototype was built by Alfonso, so he sent me the prototype. and I just couldn't run it, so I did it from scratch from save template and just copy stat over there so that it works. So we've got save template with Azure App Service deployment support, as well as Fable remoting for communication with server side. Then we use main loop and matter.js libraries for the game, physics, and then we have some ready-to-use imports or modules such as Canvas, Matter, or Physics, and I'll show you those. So if you look at my structure over here, you can see basically Matter.fs is like a module which imports the capabilities from the JavaScript library for this physics in our game. Then there is Canvas, which allows, this is like a library that allows us to cooperate with Canvas HTML5 element. And then we've got also a physics module, which will be treating like a ready-to-use library, where we have some constants determining our forces, our world, our game engine, etc. Some computations and logic related to physics of the game. So we'll just concentrate today on the client module, which is like the root of the application over here. Right. And for the server side of things, I have some shared code as well, very simple. We'll have score, which is a tuple of string and integer, so a name and a score. And scores is a score list, basically. There's a limit of high scores, of 10 high scores, which will be 10 best scores displayed on the game, in the game screen. And for the protocol communication with server, we just have two functions. We have get high scores or submit a high score, getting back high scores once again. So this is the shared module, and on the server side, there's some logic to communicate with Azure Storage, where we'll be storing a JSON file with scores in a blob. So it's already there. We won't have to worry about that. Okay, so and in the client module, there are already a couple of boilerplate lines of code. Creating the proxy to the server to communicate with the server. Then we have also a module with rendering functions to the canvas. And then kind of like a model view update architecture. So as Hian mentioned, this is like not really Elmish, but Elmish-ish. How do you say that? Even not sure. So we have a model. For now, the model just consists of engine, player, and balls, the balls, bouncing balls that you can see, and those are all objects from the Matter.js library. We'll have some messages. For now, this is just like a tick, like a frame in the game. And to initialize, we call the initialize function from physics to get those objects. Then we'll focus on the onTick function, which basically computes next state in the game, so next frame. But we'll have also the update function for other messages, as you will see. We'll add some. And finally, there's a view function which renders the stuff on the canvas. For now, we just render like this one rectangle over here that you can see. Apply some zooming to make the game fit into the canvas and actually on your mobile phones. And for now, we're just rendering the player over here. So we use this canvas module to render a shape, giving some context, yellow color, and this operator over here means basically a cast to union that fits into this model, and then we pass in the body from the Matter.js library. And also to subscribe to Canvas or the dispatch function, there's a separate function for that where we can fiddle with our Canvas or attach event handlers, and we'll be doing this over in this function here. And then there's a function in our library called canvas start, which takes this canvas HTML element, our functions over here, and basically it's like emulates the Elmish kind of an app where things happen. Okay, so that was the brief overview, and we've got a lot to cover today. Those are the milestones, and we'll move forward with each step at a time. So first goal is to add some buttons and move player around the board. Okay. So as you can see on the left-hand side, this is my Visual Studio Code editor. And on the right-hand side, it's like a Chrome with open DevTools and mobile emulator. So this is actually some iPhone 6 or 7. First thing I want to do is to add those buttons. So let me go to the view, HTML, and I already have that here. Just I'll uncomment those. So I'll have, and comment this one. So I'll have button left and button right, just like that, for controlling the game. And in the subscribe function, let me grab a reference to those. So left will be document get element by ID left, and same story for right button. And first thing I want to do is to make them a bit wider, because depending on your screen size, I want to make it like in a dynamic fashion. So I'll compute a button width property, which will be a float in pixels, and that will be the canvas width divided by 3. And I apply this style to those buttons. So with assign button width, and this is the left one, and this is the right one. If I click save, it should reload automatically in the background. As you can see, the button adjusted to 1/3 of the screen size. Okay, and now I want to add a new message to dispatch like moving the player. And before I do this, let me add a new type called dir or direction, and a direction can be either left or right, and we'll have that in our model, so the player can move either left or right or none. So basically, player is idle at the moment, and we'll have a message called move, also with backing field of dir option. So either move left, right, or just stop. Okay, so initially that will be set to none, and whenever the message comes, what we want to do is to just grab this and output current model with the incoming direction. So as you can see in the update function, there's just computing the next model. There's no comments involved over here. Okay, and we need to move the player in the on-tick. So every frame, we need to update the state. So I'll do pattern match on model move direction, and if it's none, do nothing. Otherwise, what I want to do is to invoke physics, move horizontally, so left, right, x, and x, and then there will be model.player, the opposite side, and yeah, and we need to calculate x. So x will be depending on the direction. If it's left, then we'll use a constant called player x force, whatever, and right will be player x force. So if you think of this, right is like plus, or minus is on the left side. So actually, this game 0 point is in the middle, so right goes plus this side, and left goes minus this side. Same story with y. This side is minus, and this side is plus. Doesn't make that much difference for us, but something to keep in mind. Okay, so when we apply the force, all we need to do now is to attach our event handlers for the buttons. So I'll do one more thing over here. I have that in my snippet because I can never remember that. So what I'm doing here is just checking whether there's a capability of on-touch start event handler. So that basically means mobile phones, not your desktop. If that's not the case, I just say, sorry, you cannot play the game, and otherwise we start the game. So now I'm ready. I'm quite safe to attach to the touch event handlers. So first I attach to the touch start event, the prevent default, of course, and then, come on. And then what I want to do is to trigger the left command. So this will be move and dispatch. If I click save, and if I didn't mess up anything and click this button over here, as you can see, the player moves left. But he never stops, which is not what we want. So we need some way of stopping the player, and we'll attach event handler to touch end event, and then if that happens, just dispatch move none, which basically means stop. As you can see, now I'm able to control the player more. So what I want to do now is to attach corresponding event handlers to the right button. Right. So whenever someone clicks right button, he should move right. Yep. Okay, so that concludes our first point. Move player with buttons, check. Okay. Cheers. So now let's try adding a ball to the board, actually. And this is already done within the init physics function. We just didn't. So as you can see, we initialized the engine, we initialized the player, some walls, but we didn't. We also initialized a ball or an array of a single ball, but we didn't pass it to the world. So if I add a yield over here with those balls and resave, something strange should happen. Not really. That's interesting. Yeah. Okay, I know why. Let me show you over there. As you can see, the player moved because there is a ball, but we cannot see it yet. So let's render that. Over here, we'll render balls. And for ball in model.balls, do canvas render a circle, because the ball will be a circle. Basically, context passing in style, which will be just red color, and a ball. So if I click save, as you can see, the ball is right now bouncing. Yeah, so checkpoint number 2, add ball to the board, done. Now, up to firing the harpoon. This will be funny. So to do this, let me uncomment the third button. It will be in the very middle. And also let's apply, let's grab the reference to the button and make it the same width. Okay, and fire style width equals button width. And I am not sure why, but I also need to do this for the parent element CSS. Don't ask me. Yeah, so we have the button of fire over here, and what I want to do is to attach event handler for touch start to the fire button. And for the fire button, when someone touches the fire, what we want to do is to dispatch a fire message, which is not there yet, but let's add it. Okay, so we've got the fire message, and now we want to add the harpoon. So I have a snippet to introduce a new type for the harpoon called section. So section is basically a starting point and an end point, and a point is just an x and y. And I have a couple of helper functions to my point just for later use. And we can now add the harpoon to our model, and the harpoon will be of type section option. So initially there's no harpoon. If we fire a harpoon, it will be a section that is bigger and bigger, as you will see. Okay, so initially, as I said, the harpoon will be set to none. Alrighty, and whenever someone fires, when the player fires, what we want to do is to see whether the harpoon is already there. Harpoon. If it is, it means that we need to wait until it disappears, so we don't do anything. Harpoon already there. So the game rules are that if you fire a harpoon, you need to either wait until you shoot a ball or wait until it reaches the end of the like the ceiling. You cannot shoot two harpoons at the same time. So that's what we modeled over here. And otherwise, if we have no harpoon, we want to add one. So that will be some harpoon over here, and the harpoon will be of type section. So we need to add start and end points for the section, and start will be a point from x, y, and the x will be the player x position, and y will be just the lower bounds of the world, so just shooting like from the ground. And for the end of the harpoon, it will be same x position, but for y, for the head, it will be like player position y minus player size. So you will see in a moment how that looks like. If I add that to the render function over here, this will be harpoon. So match model harpoon with none means we don't need to do anything. And if there's a harpoon, let's draw it. And first we'll draw a square, render square, context. Let's let it be a yellow color. And what it needs a size, which we have in a constant, that will be harpoon tip size. So we will be drawing a square for the harpoon tip. And the initial point will be, this will be on the end of the harpoon. So basically, I do point to tuple from x, y, and it's in the harpoon end. So at the end of the harpoon, we want to draw a small tip. So if I click fire, you can see there's a small yellow square over here. And I also want to add a line from the start to the end of the harpoon. So I'll just grab this guy over here, and this will be render line, color white. And it will end at the same point, but it will start at the harpoon start point. Start. Okay, if that reloads and I click fire, it's really small, but as you can see, there's a line from the lower ground to the tip of the harpoon. And the harpoon is currently static, it doesn't move, so we need to change that. And we'll move to the onTick function here and see if we have a harpoon. And if we have no harpoon, just output the current model as we did before. And otherwise, output a model with harpoon updated. So we'll add a function called moveHarpoon, which we'll need to implement over here. And the harpoon will be of type section. And for now, let's do just some harpoon with end equals new end. And the new end will be the same point, move vertically by the harpoon step, minus harpoon step, because it will be going up. And we'll use harpoon end for that. So we're moving the previous position of the harpoon end to a new position. So right now, if I click fire, it should go up. But it goes up indefinitely, so it doesn't stop at any point, which doesn't make any sense. So let's prevent that from happening. And we can check if the harpoon end reached the end of the world by checking whether it's less than bound upper. And if that's the case, then just dismiss the harpoon. And otherwise move it up, which means that if we now fire the harpoon, it should disappear when it reaches the ceiling. So I can shoot another harpoon just when the previous one disappeared. Okay, so point number 3, firing the harpoon, check. Okay, so what's the next step? Shooting balls. Okay. So this is actually when the fun starts. We need to somehow calculate collisions between the harpoon and the balls and split the ball into smaller ones. So to do this, let me go over here. So this is where we detect that we have a harpoon in the onTick function. So basically every frame, and we'll see over here what I want to do is to detect the collisions. So I'm using a ready function for that, which is called castray, and it takes an array of objects to look at, which as a first parameter. So for each of the balls, we want to see if there's a collision from the harpoon start to harpoon end. So we give it a section and an array of objects, and it looks for collisions between those. So let's see that in action. If collisions length is equal to 0, then behave as we did before. Just move the harpoon, and otherwise dismiss the harpoon. So if we detect a collision, we should hide the harpoon. So let's see how that's work. As you can see, when I touch the ball with the harpoon, it disappeared. But the same story happens when the ball touches like the only the line of the harpoon. So that's the rules of the game. Okay, right. And now that we have detected the collisions, we can try to split the balls. So here, what I will do is to introduce a new function called ball collisions, and it will take 2 parameters, current model and all the collisions. Okay, so I need to add that function at the top. Current model plus collisions of type matter I collision, so just an interface from the matter JS library. And what we want to do is to check for iterate through all collisions and calculate other next step, like next balls. And so we can do this, for example, by using array fold. I pass it like that, like in a tuple. So fold through all collisions and collision. Oops. And just for now, return balls to compile. Okay, it compiles, cool. And I'll pattern match, because collision has a body A and body B. So basically, two objects have a collision. But in this case, I'm sure that the ball will be body A because I passed that as the first argument to this function. So if the body A is a ball, physics.ball level as ball, I'll explain in a second what that means. Then do this, and otherwise do that. And actually, this should not really happen, but who cares? Okay, so what's here is like an active pattern in our physics module. And what I didn't mention is that every ball has its levels. So we start with the biggest ball of level 1, and we split the ball, it will get double levels. So after we split level ball 1, we'll have 2 balls of level 2. When we split a ball of level 2, we'll have another 2 balls of level 4, level 8, etc., etc. And based on the level, we calculate the size of the ball as well as speed of the ball. So that's already handled by the physics engine. Okay, so over here, what we want to do is to create new balls based on what the ball that we shot was. And what I'll do here is to create an array force x in minus ball x force and ball x force. So first ball will go left, and the other ball will go right. Okay. Create a new ball, level doubled, and then what it wants else, just the force, right. So go left or right, and the position. So we have model position. Sorry, not model, ball. So the ball that we shot, position X, and ball position Y. Okay, so those are the new balls, and now we need to add them to the physics engine. And we'll do this by invoking add balls on the physics module. And we'll need a reference to the world, which is in our engine, and add those balls like that. Okay, and we also want to remove the ball that was shot. So we use a remove ball function over here, passing in the ball that was shot. And we return, because we want to bind to our model the new array of the balls. So we filter out the ball that was shot, and instead we'll append new balls over here. Okay, so if I click save, and if it reloads, and I click fire, oh, missed one, sorry. Okay, as you can see, it splits. Awesome. So point number 1, for shooting and splitting balls, checked. Now let's go and count the score. So for each ball shot, we'll get a single point, and we'll track that in our model. So we'll have a score field of type integer, and initially, of course, this will be 0. And whenever we shoot our balls, where's that? Over here, we just add to this score the amount of collisions, right? So as many collisions as we had with those balls, this means we add so many points to our score. And we can display current score in the view function using render text. And let it be white color, and position will be 0 for X, and text position for Y. And then just the score model.score. Okay, this is a float. Okay, so we've got the score. When we manage to shoot a ball, it gets increased. So the game is quite funny now. But as you can see, I'm like in a god mode, so the balls cannot kill me, which is doesn't make any sense, probably. So let's try to handle game over, because the game needs to end eventually. To do this, we'll just add a new discriminated union type, call it game state. And game state can be either playing, which means we are playing at currently, or just game over. And add that at the very end of the model, state of type game state. Obviously, initially, we want to set that to playing so that we start playing immediately. And how do we detect game over? We could do that potentially in the onTick function, but instead what I'll do is to subscribe to all the collision events in our subscribe function over here. So I have also a function called onCollision where I pass in the engine and handler for the events. So I'll add a collision message and compose that with the dispatch function. So I need the collision message in our type, and the collision will have a pair of objects. So this is like a iPair interface. Okay, so now back to the update function. What I want to do when the game is over is just to freeze the engine. So do not update any frames, etc. And to achieve that, what I can do is to pattern match on every single message whenever model state is equal to game over. And if that's the case, just output the current model, so no frame update, etc. And now let's try to pattern match on collisions. And here I have also a helper active pattern in physics, and it's called pair. So basically, this is an active pattern that I pass two predicates or two functions, and it checks whether either of those objects from the pair conform to those predicates. If true is for both predicates in this case. So I'll use that here. So pair, and I need a tuple of predicates. So first predicate will be equals model player. So this is our player, and the second predicate is physics is ball. So the second object is a ball. And if that's the case, then the game is over. Model with state equals game over. Right, and any other collision over here, well, we'll just ignore. So output model. If that works, then when the ball touches the player, the game freezes, which means we have game over state. Okay, so point number 6, handling game over, done. But the thing is now that when the game is over, I have to refresh the page, which is not the best user experience because I didn't handle restart the game. So instead, we'll just restart the game automatically whenever we lose. And to do this, we'll write a small function called reset. And it will be recursive. I'll tell you in a second why. And all the reset function will do is just to initialize the canvas with those functions, so just like to reset the state altogether. So we'll invoke that over here. And I did it recursive because I want to pass this function to the update. And whenever we end up here, what I want to do is to reset the game state. Pass it over here. Right, so what happens now is that whenever I lose the game, it should start from scratch automatically. No matter how many score I get, how much points I get, the game restarts automatically when I lose. Okay, so point number 7 are done. Okay, now up to implementing high scores. So this is the point I hope I have good connection because internet connection because we'll be fetching the scores from Azure storage. So hopefully everything goes right. And first thing I want to uncomment the high scores section just beneath the board. And upon the start of the game, let me actually add a ready to use function from my snippet, which is very boring, just rendering scores. It takes reference for this scores section in the HTML, and basically for each scores from, as you can remember, high scores were basically a list of name and score tuples. And for each of those, just create a list item and display beneath. We'll see in a second how that looks like. Okay, so what I want to do over here is to start an asynchronous computation expression. Start immediate, and here we'll be using Fable remoting to fetch scores from Azure, get high scores, and when we get the scores, we'll use the render high scores function here. Click save, and if I have good connection, then I should get back the bitme 1 points, which is what I pre-populated the Azure storage with. So yeah, the connection works, which is good. And what I want to do now is to add logic upon the game over to see if we get a high score. And to do this, let's create, where's that? Here. Let's create a function called gameOver, which will pass as current score and the reset function. And for now, we'll just invoke the reset and async start immediate. And we'll invoke gameOver, passing in this score and the reset function here. Okay, so what now? We are playing the game. We have some scores initially, but after we end the game, the scores could change in the meantime. So we want to fetch the scores once again from the server. So we do this here. Server API get high scores once again. And now let's see if we get a high score. So my business logic for that will be if scores length, so if there's high scores in the Azure, there are less high scores than my assumed limit, which is 10, as you can remember, then the score is a high score unless it's equal 0. So whenever there are less than 10 scores, if you get a score higher than 0, it is a high score. And otherwise, this high score is if the score is bigger than lowest score from high scores. And the lowest will be scores pipe to seg map second. So as you can see, scores are tuples of name and score. So we've got now just sequence of scores, and segmin should give us the lowest score. And now, if it is a high score, then we want to ask the player for his name, because we want to submit the high score. So we'll grab that using a prompt, because why not? And it will say, high score, what's your name? And pass in the score. Okay, if you get a prompt, you can cancel it or just type in an empty string. So if that happens, we'll just put in anonymous string instead. So if name equals empty or is null name, then it will be like that. Anonymous, yeah, whatever. Else name. Okay, and now we can submit the high score to the server. So we do a server API submit, come on, submit high score, name score. Does it work? Not really. Something's. Where's that? Here? One.
From line 164 downwards, need to untab.
See. 64 here. Right. If it's high score, then no. Why is that? Okay. Yeah. Now I can see. I told you the code will not be very clean. Okay. Updated scores, and we can render those updated scores now. Thank you. Yeah, I did that when I was practicing. So thank you. Okay, real name, and then otherwise, if we don't have a high score, just render the scores that we got from server because they could change as well. Okay, and lastly, just reset the game. So now, if I click save, and if I do better than 1 point, then I should get a prompt for a high score. So let's lose. Oh, yeah. Okay, so high score, what's your name? T. Heimowski, click enter. And it should restart with an updated high score ladder. So, okay, point number end, 8 high scores done. We're ready to ship our cool game to Azure. So let's do this. It's already using ready fake target from the save template. So we'll deploy that to app service in Azure. And when that's finished, I'll share a URL with you to scan and also tweet that. And you can start playing. And we're looking for the best player. And after Chris' talk, we'll give this book to the best player. Okay, so. Yeah, so that was my intent. Okay, so the deploy to Azure is an interactive process, so I need to grab this code over here, click the URL, and paste it over here. Yes, continue, sign to my account. All right, so in a couple of seconds, hopefully, or a longer while, it should be already done. And yeah, so that's pretty it. Thank you for listening, for bearing with me. And the source code will be published to GitHub in this link. I'll tweet also the link to slides. If you want to reach to the links, there are not that many. So yeah, anyway, it should be done in a second, hopefully. So I have already that resource in Azure. I have already created that resource in Azure, so it deploys to this endpoint over here. And this is the QR code. So grab this one with your mobile phones. I'll also tweet that in a second. And we can start the competition. Yeah, probably. I haven't really tested, load tested the application, so let's see if it crashes. Can you scan it, or is it too big, too slow? It's okay. It should be. It's working. Okay, it's fun. This is actually funny because I'm just uploading, you're playing the previous version, which shouldn't really change from the one that I'm uploading right now. But in a second, you'll probably get connection loss because it's uploading like to the same endpoint a new package. So if it doesn't work, just refresh and it should reload. The scores, high scores should stay the same because it's stored in the Azure blob. But let's see. Site under construction, right. So right now the new package was deployed and it needs a while to refresh. But hopefully in a second we'll have already that running. Shall I go away already, Alfonso, or do we have 1 minute more? Yeah, okay, so I just, hopefully it works. Okay, this is game for, let's see. Refresh. Right, so, okay, we can see anonymous 6 points, maximum 5 points. Okay, so the competition starts. After Chris' talk, we'll give away the book to the best player. Okay, good luck. And thank you.